Here's our spherical mirror, concave. Our scale, each grid line is going to be 3 centimeters. So let's see, if it has a radius of curvature of 30, that means its focal point is 15 centimeters, which would be right here. And our object is located at 5 centimeters, right about there. And it's 10 centimeters in height. So I think we're pretty well set now. We can start our ray tracing. So the first thing I'm going to do, I'm going to use, let's see, red for my first ray. And this line is going to come in parallel and it comes out through the focal point. Like that. And our second ray will be blue, and it comes in through the center of curvature. Center of curvature is out here. It comes in through the center of curvature and back out through the center of curvature. So right about there. And I can already see I'm going to have to trace back to see where my image is going to be. So in other words, if a light ray came in along this path, it would reflect back out along the same path. If a light ray came in along the red line, it would come out in this direction. And so what we're going to have to do is extrapolate back. Let me start with my blue line. The blue line goes off in this direction, roughly. And the red line goes off about like that. And let's do another one. Let's do a ray going to the vertex. So we will have, how about green? So this one comes in this way, and it reflects with an equal angle and comes out over here. Something like that. And then let's just carry it back in the other direction to see where it would have come from. We have to trace back this way. Right about there. Okay, so I like to draw 3, and those 3 are in roughly the same location. So that means that my image is somewhere over here. You have to be, the more careful you are with your drawing and the larger you make it, then the less errors there are. But this is not so bad. I've got 3 lines intersecting in roughly the same location. And so here's my original, my object, and here's my image. What we want to do is punch in the numbers here just to see how close we came. And so the equation we use is 1 over the object distance plus 1 over the image distance is 1 over the focal length. And the focal length for a concave mirror is positive, so in our case we've got positive 15 centimeters. Our object distance is positive 5 centimeters. It's in front of the mirror. And I plug those in, and I end up with S prime is negative 7.5 centimeters. So it's going to be a virtual image. It's behind. The negative sign tells us it's behind the mirror. It's a virtual image. And that's what we got. The magnification, now we expect, our drawing tells us our image is actually larger than our object. So let's see. The magnification is given by negative S prime over S. And I get a positive 1.5. So the 1.5, the magnitude of the magnification tells us how big it is. It's 1.5 times the size of the original. And the positive sign tells us it is in the same orientation as the original. So if the object was pointing up, this image should be pointing up. And that's what we got. And it looks like it's about 1.5 times as big, so not too shabby. Oh, what did we get? We got 7.5 centimeters for our location. And let's see, this would be 3, 6, 7, 8. Yeah, I got about 8 on my drawing here. So not too bad, 7.5. So the drawing looks pretty good. So it's going to be 1.5 times as big as the first one. If the first one was 10, then if the object was 10 centimeters, which it was given, then the image is 15 centimeters. Position is negative 7.5 centimeters. I guess I could just write them here. Size is 15 centimeters. The orientation is same as object, or upright. And the nature, it's a virtual image. So now we'll move the object to a different location and do it again.